Seaford Secondary College, 13 problem solving strategies. Don't give up, show some resilience.
Joe's car is 5 centimetres long, his dad's car is 4 metres long. How many times as long as Joe's toy car is his dad's? So that sounds a bit wordy, but let's break it down. So Joe's car is 5 centimetres long and his dad's 4 metres, which is the same as 400 centimetres. So what we're going to do is we're just going to guess and check because it's a multiple choice question. So over here I've got, well, 1 times 5 is 5. I know straight away that's not an answer. Okay, so let's go, well, 20 times 5 is 100. Oh, I can see I'm starting to get a bit closer to it, but again, 20 is not the answer. If I do 80 times 5, that is 400, which is our answer.
Alright, looking at the following question here, teacher wrote a 3-digit number on the board and you've been given some clues. Using the problem-solving strategy of deduction, we can use our statements to work out which one is a true statement for those questions and eliminating any that are not true. Alright, so let's start with the first statement. The number is even. So options A, B, C and D, we can see that C is the only odd number. So we can start off by eliminating that number. So we've got 3 options left. Moving on to the second statement, the 100 digit is 2 less than the tens digit. So we have to have a bit of an understanding about place value here. What I'll do is I'll just identify the hundreds and tens on my 3 remaining questions. And reading the question, 2 less than. So here, that's true, the hundreds digit is 2 less than the tens digit. Here, the hundreds digit is true, it's 2 less than. But here, the hundreds digit is actually 3 more than. So that's the second one we can eliminate. Alright, so moving on to our final statement, we can deduce which answer is correct. So the sum of all 3 digits is 12. Question A, 4 plus 6 plus 2, that equals 12. So that's probably our answer, or that's a true answer. Let's just confirm that B is not true. So B, 6 plus 8 plus 4, 6 plus 8 is 14, that equals 18. So this statement is not true. So that leaves us only with A being the correct answer to this question.
So today we're going to look at 2 different strategies. In maths we're going to look at deduction and direct calculation. So we've got this question here. The athletics carnival started at 10:30 a.m. and lasted for 2.25 hours. Rose went straight home after the carnival finished. She took half an hour to get home. What time did Rose get home? So we've got these options down here. We've got 12:45 p.m. We've got 1 a.m, 1 p.m, 1:15 a.m. and 1:15 p.m. Now if we think logically, we know that 10:30 a.m. Is in the morning, so we also know that 1 a.m. is in the morning and 1:15 a.m. is in the morning. So we know that she's not actually going to get home at those times because that would be before 10:30. So we can instantly cross those 2 out, which means that we've only got 3 that we need to work with. So if I look at 10:30, and we know the next part of it is that the carnival lasted for 2.25 hours. So we've got 2 hours and 1/4 hours. We know that 1/4 of an hour is 15 minutes. So if we go and add those things up, so if we get 10, 30, and we know that it's 2 hours and 15 minutes, we could add that up and we'll get a 4 there, 2 there, and a 1 there, so we get to 12:45. Rose then went straight home after the carnival, but it actually took her half an hour to get home. So we know half an hour is actually 30 minutes. So if we add 30 minutes onto this, we get a 4 and a 3, which gives us 75. We know that we can't actually have that. So we're going to end up with, because there's only 60 minutes in an hour, so we're going to have to carry 1 over here. and 1 left over. The 1 gives us 13. Now, if we know in 24 hours, 13 is actually equal to 1. So it ends up being 115. So we end up getting this one here.
Okay, so what we're going to do is use the problem solving strategy guess and check. Here I've got a table with the top number and the bottom numbers, and essentially I'm looking for a pattern that will help me find what this question mark is going to be. So if I look at the top numbers, I can see they're going up by 1 each time, and the bottom numbers are going up by 3. So I know there's a pattern here. If I were to times the top number by 3, that'll equal the bottom number. So when I'm looking for the question mark, what I'm going to do is reverse it, because if it's multiplying going this way, it means that I can divide 3 going that way. So 27 divided by 3 should give me 9. The German number 9.
Well, this is a solid made by 18 cubes. And we're asked how many cubes are completely hidden. One of the strategies is restate the problem. How many cubes can I see? Well, here's one I prepared earlier. 1, 2, 3, 4, 5, 6. They're at the bottom. 7, 8, 9, 10, 11, 12. I can see 12. 18 in total. That means 6 must be hidden from view. Restate the problem. 6, champ.
So in this problem, we have square or rectangle plus 134 is 3 times 76. So we can write that out as a number sentence, or we could work out the answer and work backwards. So what we might do here is 3 times 76, work that out, and then minus 134 from that answer. So we're working backwards. So we have an answer, 228, which we subtract 134 to give us 94.
Problem solving method number 4, direct calculation. James wants to buy a jacket like this marked at $180. He is given a discount of 10%. What is the value of the discount? A few different ways we can do this. First, you might want to convert this to a decimal. So to do that, I go 10 divided by 100, give me 0.1, and I can multiply that by 180, give me $18. Another way I can do this is, I've got 10%, how many 10s go into 100? 10. And then how many go into 80? 8. So add that together, $18. A few different ways you can do it.
The square table has 4 corners. If you cut off 1 corner, how many corners are left? Well, it's easy to think that you go, I've got 4 corners, I take one away, I've got 3 corners. This would actually be 1. So let's take a moment to draw a diagram to see what happens. So here I've got a square table, and I've got 1, 2, 3, 4 corners. Well, if I cut off a corner, I can erase that, and we've got 1, 2, 3, 4, 5 corners. So drawing a diagram can help you get your answer.
Stop! Be resilient. Don't give up. In this particular problem, we need to interpret the context. Two on 1/3. Go back. Between 2 and 3. So our long jumper is a bit under half. Which process of elimination? It's less than a half. It's certainly not 3 2/3. It's certainly not 2/3. So through process of elimination, we've got our correct answer, 2 1/3.
So, this strategy is making a list and restating the problem. We have 4 different kinds of fruits, and we have different prices and different weights. So we want to make them all the same per something so that we can compare the most expensive. Now looking at these numbers, I think we're going to go right in the middle at half a kilo, 500 grams. So I'm going to make a list where all of these are the price for 500 grams. Come over here. My apricots, 90 cents for 250, double it, $1.80 for 500 grams. $3 for 750. I only need 2/3 of that, just 500. Let's make that a nice round. $2. $3.80 for a kilo. Cut it in half, $1.90. And lastly, no stress for this one, it's already $1.70. Which one's the most expensive per mass? Grapes.
So often there's more than one way to solve a problem. In this particular one, with 4,000 people and 3/4, I'm actually going to look at dividing by 4 by using a shortcut. And now I'm going to work out, in terms of the question, the 3/4 and the 1/4, how they belong to the 4,000. So 4's into 1,000, 1,000. I've got 3/4 undercover, which is 3,000. Subtract from 4,000, there must be 1,000 people left over that are undercover.